Global synthesis identifies critical and non-critical paths before structuring. Thus, Cadence can better differentiate critical parts from non-critical ones and structure them differently. Let's check out different cell types and leakage optimization to be used. The first circuit shows critical paths mapping. Critical paths are structured with smaller, narrower cells to help place and route close timing easily. These cells have more sizing options for place and route to use, and here low threshold voltage cells are used, which have characteristics of high leakage power, larger driving current, higher sensitivity, and higher speed. If you talk about non-critical mapping, these non-critical paths can be slower but more compact and use high threshold voltage cells, HVT. These cells saves on the area and leakage power. These kinds of cells have characteristics of lower leakage power, smaller driving current, lower sensitivity, lower speed, and they can reduce 10 times in leakage power. Still, at the same time, they are slower. The synthesis tool can also use medium threshold voltage cells that are medium VT, MVT, which considers the trade-off between HVT and LVT. Cadence supports multi-VT libraries. Cadence can optimize your design accordingly when you provide a multiple threshold voltages library. If you want to optimize leakage power, it will choose high VT cells along the non-critical timing path and choose low VT cells only as needed on the timing critical path. The Cadence LP engine uses all VT libraries during each optimization step by default. It automatically chooses low VTH cells with timing critical path and a high VTH cells with a non-timing critical path. Let's check the circuit. For example, you have this blue, where you're optimizing using high VTH cell for your power optimization. For the red, the tool uses low VTH cells that are high speed to optimize for timing, maybe this is a timing critical path. And otherwhere else, you can use the normal VTH cell.